Hello friends, welcome back to my channel. In today's video, we're going to look at an MLOps project about model and data drift detection and automated retraining workflows. Now in the past video, we did look at the Kolmogorov-Smirnov statistical test for detecting drift in data. So in this new project, we are going to look at how to use the packages Scikit-learn, Alibi Detect, which is going to utilize the Kolmogorov-Smirnov drift detection package to detect data drift. And then we are going to use Apache Airflow to automate the retraining of our model whenever drift is detected. Now, our script is going to be such that when no drift is detected, the retraining process is skipped. So stick around for the entire video. Like, comment, and subscribe to my channel for more videos. And now let's get into it. Let's look at the components and set up our environment for this project. At first, we are going to do model training. And so we need a package for our model training, and that we are going to use Scikit-learn. For our model drift detection, we're going to use the Alibi Detect package in Python, and that has the KS test in there. For our training pipeline orchestration, we are going to use an Apache Airflow DAG. All right, so all the instructions are in this README below. If you go to the GitHub repository, link in the description below, you would also get access to the GitHub repository. I basically cloned it locally. So to start, we have to create a folder structure. I use this command to create it and also to cd into it. So run this command here. So you can see that now we are cd into the MLOps drift detection directory. Then we are going to create some directories that we are going to use later. One for data, models, drift detection, Airflow DAGs, and retrained models. So use this command to create all of these directories in the MLOps detection. So if you go into the MLOps detection, you see that all of them are right there. Now that we have that, let's set up our environment. I don't want to use my global Python environment, so I'm going to set up a Python virtual environment. And we are going to call our environment ddrift env, meaning data drift virtual environment. Create this. Once that is created, we have to activate it. The source command. So you can see that it's activated now. Next is to create our requirements.txt. So we are going to use touch requirements.txt to create a requirements.txt file. Now the content will be right here. Just copy this and add it to the file. Save it. Now this is basically the packages that we need. We have the Scikit-learn, pandas, Alibi Detect, and Apache Airflow. Let's prepare our training data. Now for simplicity, we're going to use the famous iris dataset. Now for that, still inside the MLOps drift detection directory, we are going to log into the data directory. So use cd command to log into the data directory. It's currently empty. So we are going to create a Python script called prepare_data.py in that directory. There it is. I'm going to open it right here. And I've prepared a script here that I'll copy and add to it and explain it. Copy this. Now the script is importing pandas and Scikit-learn, which loads the iris datasets. The iris dataset is actually inside the Scikit-learn package. So we are creating a function here called save_iris_dataset. And it's going to load the data and save it as iris.csv inside this data directory. That's all this function is doing. And then this is just there to help us so that whenever we run this command here, it's able to run this script. All right, so we are already inside the data directory. So let's go back so that I can use this full command here that I copied. The claims pandas is not found. Okay. Yeah, I forgot that after creating the requirement.tsc, I didn't install it. So I'm gonna modify the readme and I'll add pip install -r requirements.txt. The requirements.txt is in this same directory. So let me clear the screen for now. So I'm gonna use the exact same command here to do the installation. Okay, that is done. Let me clear the screen again. And now we can run our prepare_data.py script again. Copy this, run this command, and that should save the iris.csv inside the data directory. So this is data, and you see the iris.csv is right there. If you click it, this is the iris data set. All right. Now that is part one. Part two, we are going to look at how to train and save our machine learning model. And for that, we're going to use a random forest classifier model. Okay, now let's train our random classifier model. Let me clear the screen first. This time I need to cd into models. So cd models. And then I'm going to create another script called train_model.py. You should create it inside the models directory. This is it right there. I'll open it in a new tab. Let's close these two. Okay, and the script is right here. I'm gonna copy it and explain it later. Copy this, paste it in here. Let's go through what the script is actually doing. First, it's importing all the necessary libraries. We have pandas, pickle. Pickle is the extension file for our model to help us to be able to save our model. We have date time. We're going to need time somewhere in here. Then Scikit-learn for our model, which is a random forest classifier. And then you will need a training and testing split because it's a machine learning model. So we need that. So we have one function called train_save model. The first part here is just loading the data. Remember, the data is inside the data iris.csv. X, everything else apart from the target variable we are predicting. So this is going to drop the target column. Again, I can open the data set iris. This is it. The last column where you see 0, 0, 0, 0, that is the target column. So we are dropping that, and everything else is going to be our data points X. And then that target column that we dropped, that is our Y. Next, we will do our training test split. And we are going to do 20% for testing and 80% for training. And we are setting a random state of 42. And so we get all the X and Y test and train data sets. Next is where we actually train our model. We call our random forest classifier model. We are calling our model CLF. And so to fit it to our training data, you just call clf.fit and then xtrain, ytrain. Next, you need to make sure that these two directories are available, models and retrained models. Models is right here. That's where we are in. And retrained models is right here. Both of them are available. This will just do the check. Next, we are going to save the model that we trained. So this will just save the original model that we are training. Now, this is just going to generate the time at which we trained this model. And we are only doing this for versioning sake. I want to version it. So that's why we are doing that. And then suppose in the future, when we check for the data drift and it comes up that our data has actually drifted and we need to retrain the model. When we retrain the model, we are not going to save it inside the models directory like we did the original or the base model. We are now going to save it inside the retrained model directory, which is retrained model directory right here. And in order to identify it easily, we are going to tag it or version it using timestamp, which is also why we had to import datetime inside our script. And then we will save that. And then this will just help us to run the script. All right. So back to our README, I'm going to scroll down and we are going to use this command here to run the script. Now to use this command, you need to be outside of the models directory. We are currently inside it. So you have to run cd ... Now you can paste this here. So you can see that a model has been saved inside the models directory. And then there's one saved inside the retrained models directory. Now at this stage, we are going to look at how to implement a drift detection. Now, since this is a tutorial, I'm going to manipulate the data a little bit to result in a data drift. Okay. Now, aside that, once the drift is done, or once I've modified the data a little bit, I'm going to use the Alibi Detect to monitor the drift and to catch on whenever there is a drift in our data. So to do that, I'm going to cd into the drift detection directory that I created earlier. Let me clear the screen first. So I'll cd into drift detection. There's nothing in here currently. So I'm going to create two files. One is going to check for the drift, and the other is going to be creating the drift itself. So that is this directory right here. I'm going to expand it. These are the two files that I'm talking about. I'm going to close this. This will generate the drift, and this will check for the drift. I have the script here. I will copy this. Paste it in here. And then there will be another one for generate drift. That one will be right here. Copy this. It'll be somewhere here. Copy this. Drifted data. Save both files. Now let's look at how we are generating the drift first before we can actually check for the drift. So of course we are importing pandas and numpy. And then we have one function here called create drifted data, which accepts two inputs, input path and then output path. Now at those paths, there will be files there that it will pick up. First, we have a df, which is loading the input path. We have a df drifted, which will create a copy of the inputted file called df. It will take all the columns inside the df file or the data sets that we actually have, the arrays data, except for the targets column. It will take that and then use this to add some drift to it. And it's doing that by scaling it with a random distribution variable or quantity with mean 3 and with standard deviation 1. Now this will be used to drift the original data in all the other columns, okay, apart from the target column. So this will drift it and then it will save it as an output path. So whenever we call this function create drifted underscore data here, we just need to give it two paths. One path is for the input. This is the original location of the data. And the other part is the output. This is whatever data that we end up with after doing the drift. That is how we will generate the drift. So let's actually generate the drift first. I'll copy this command. I'll go back again. Then I'll paste this here to generate drift. So that's been saved inside data iris. That is iris drifted. Next is the drift detection. So this is what's going to detect the drift. So we are importing pandas, numpy, and then you see Alibi Detect. That is what will do our detection. And we are using KS drift, and that's the Kolmogorov-Smirnov statistical test. So we have a function here called check drift. It has a reference data path. It has new data path. And it has a p-value threshold. That is our significant level. You know, in statistical tests, the alpha level 5% usually. First, you load the reference data. The reference data is our normal data, the original iris data sets that we use to train the model. And then, of course, the reference data X is everything apart from the last column, which is for the targets. And then we have our simulated data, or the new batch of data that just came in. That will have the new data path, which will basically be the iris underscore drifted.csv. And for that, when we drop the target, that will be our new underscore X. So this is where we initialize the drift detector. So we call KS drift, we give it the reference X, and then we give it a p-value threshold, which is our 5%. Now we can check the drift by calling this KS drift, which we call detector, and we give it the new X, which is right here. and that will give you some predictions. Now the prediction can either be drifted or none. That's what we have here. And then we will get our p-values as well. If there is drift, it will output drift detected, and it will show you the p-value. Else, it will show no drift detected, and it will also show you your p-value. And so this is a reference path, and this is a new data path. So that's our script, pretty straightforward. So you use this command here. Press enter, and that should train your model. You don't need PyTorch and TensorFlow here, so you can ignore the first part. Now in the last part, it says drift has been detected. Okay, if drift has been detected, that means our p-value was actually less than alpha, right? So our p-value was less than alpha, and you can clearly see it here. So that's how you would detect drift in data. Next, since we've detected drift, we have to retrain our model. So we want to automate the retraining of our model using Apache Airflow. That's what we are going to do next. So at this stage, we are setting up our Apache Airflow, and we are going to use Docker and Docker Compose to set it up. Now, in the past, I already uploaded an Apache Airflow tutorial on my YouTube channel. If you scroll down here, you should see it somewhere here. This is it on the far right side here. I set the Airflow up using a different kind of setup. So if you don't want to use Docker, you can use this way to set it up as well. So to set it up with Docker Compose, you need to run the script. And this is going to download the Docker Compose.yaml script. So I'll clear the screen here. When I paste this here, this should download the compose file. This is it. I can open it. So this is our Docker Compose file. All right. Now that we have our Docker Compose file, now when you're setting up Airflow with Docker Compose, you need to know your host user ID. Because you need to set up some directories, you will later on set up directories, DAGs, logs, plugins, config, etc. If you don't know your user ID, when you try to create these directories, it will be created with root ownership. That's why you need your user ID. We are going to create this directories here. Paste this here. See that we've created even more directories here, config, DAG, and so forth. Now this is where you get a user ID so that we can still run it without root privileges. And you see the .env right there created. Next is to initialize the Airflow configuration. We're going to run the command docker compose run airflow CLI, airflow config, and list. Copy this command to initialize Airflow. All right, so you can see that there's some error here. It's indicating unauthorized personal access. And if you read down here, you see unauthorized personal access token is expired. And this is coming from Docker Hub. I don't have a available Docker Hub token on my system, so that's why I'm getting that error. So to correct this, just go to your Docker Hub account. Just gonna do it quickly here. Just sign in into your Docker Hub account. Once you are in your Docker Hub account, go to your user here, account settings, go to personal source token. So all of these are expired. Let's see, that's the reason why. Generate new token. Let's just call it drift or for data drift. 30 days. Say read, write, delete. Generate. Okay, so it's generated the token. So I'm going to copy this command here to log in on my terminal. Paste this. Docker login, it will ask for the password. The password is a token here. Copy and paste it here. Press enter. And we are successfully logged into our Docker Hub account. Okay. So I'm going to clear the screen now. And then I'll rerun this Docker compose run command again. Right. Press enter. All right. So the container has started running successfully. I'm going to create a new bash terminal. And of course, for that, I need to run the source command again here to activate the virtual environment. Here it is. Yeah, I need to go into MLOps, run the source command. Okay, so this is also activated. Let's go to the previous one again. Now let's continue from where we left off. So this was the command we ran earlier. Now we need to initialize the database to create our first user account. Usually when you set up Airflow, your first user account is going to have the login, user ID, Airflow, password Airflow. So use this docker compose command app. Paste it here. Next is to now run all of Airflow in tandem. Okay, piece everything together using docker compose app. So basically over here, we turn up every dependency for Airflow. So when you run docker compose app, now that pieces everything together. So docker compose app, and now this should start running your Airflow. Now this is going to run it in watch mode. That's what you can see here, which means it will be constantly up monitoring any task that you're doing to see if there is a job for it to pick up. Since it's going to run in a watch mode, that is also the reason why I needed a new bash terminal, because the rest of the commands you have to run it in a different terminal. So I've added a comment here. So in a second terminal, check your Docker processes and see whether it's healthy or not. Right. So I'm going to use Docker PS. And you can see that all the containers are up and running, and all of them are healthy, as you can see here. And so now we can go to our web browser and run localhost port 8080. Hit and go, and that should load your Airflow. Username is Airflow, password is also Airflow, and that is your Airflow GUI. Now there are several ways you can access Airflow. Of course, here we use the web interface using localhost. You can also access it using a REST API by using this command, but it's optional. So the next stage, we are going to create a DAG for our Airflow, which will automate our retraining workflow. So I'm going to clear the screen here. By the way, the Airflow is still running on the other terminal. You have to leave that running. So I'm using the second terminal. Let's do ls and now cd into DAGs. Now remember when we were setting up Airflow environment, we created some repositories, some directories. So the config will contain the Airflow configurations. This will contain the plugins. This will have the logs, and this will contain the DAGs. Now the DAGs is essentially the pipeline that we are creating with Airflow. I have to go into that DAGs directory that we created. And that's where I will create my Airflow pipeline script. So that was that. And now I'm going to create this drift retraining dag.py command in that directory. This is DAGs, and this is the file I'm talking about. And for the content, I have it here. I will just copy it and paste it in there. Right here. Paste it here and save it. Now let's go briefly through the script and see what it's actually doing. So of course, it's importing Airflow and Airflow operators. Now in this case, we are creating a DAG, which is a pipeline, and we are also going to use Python operators. Now for the Python operators, we have the ordinary Python operator, and then we have branch Python operator. The reason why we need both of them is because, so when we check drift and there is no drift, we want our pipeline to skip retraining of the model. But when there's a drift, we want the pipeline to actually retrain the model. So that creates something like a branch. So you would see that at the end here, where we actually write the DAG with DAG function there, we specify our DAG ID, specify the schedule. At the moment, we will use manual trigger, so we will give it none. If you want to automate it per day or per hour or per minute, you just put the date there, kind of like a cron job. So you have a start date, description, tags, and so on and so forth. So We are going to create Python operator to retrain the model, all right, and a Python operator to not retrain the model. Whether to retrain or not is dependent upon drift detection. Now for that, because there are two different cases that could happen, it's always advisable to use a branch Python operator instead of just the ordinary Python operator in Apache Airflow. And then later on, we come here to call the different functions or the different branches in our pipeline. So let's go up then and start over. First is to decide retrain branch. So this will run the drift detection script and decide whether to retrain or not. And remember, the drift detection script is inside the check_drift.py, which is this file here. It will check that, and then it will look at the output, to the standard output, and then query it to see whether there is a drift or not. If the drift is detected in the output, then we are going to retrain the model. If no, then no retrain. This is the retrain model task, which is a function here. This is just going to retrain our model, which is just to use Python and the file name to train the model over again. If there's no drift and we have to skip it, then it will run this function skip retrain_task, which will just print no drift detected. And so it's skipping retraining. Very simple functions here. And then of course, this is the DAG that I just explained. These are branches and so forth. And then this will be the steps for Apache Airflow to follow for retraining. With that ready, I'm gonna have to expose this drift training DAG script to our Apache Airflow. And we can do that using environment variables. Wherever that your DAG is, you have to expose it to Airflow or to your environment. So you can use this command here. Copy this. Sorry, I'm actually inside the DAG directory. I need to get out of it and expose it this way instead. To start the Airflow scheduler, which will actually start the Airflow tasks here, I'm just going to make a few changes here. I will add data_model_drift detection and retraining. And then for the tags, I'm going to add some extra tags, let's say ML, AI, so that it's easily identifiable. Save this. Now let's schedule. Airflow scheduler, run this command here. Paste this. See, Airflow is already initialized here. Now it's at this point you go to your Airflow web page. So when you open it, you'll be here. You go to DAGs, and now you look for our specific pipeline. By the way, I changed the name a little bit. So this is the data_that. You can also filter using tags. Remember, I added a tag called ML AI MLOps drift detection. Let's use ML. You have MLOps. Yeah, there it is. So this is our Airflow DAG. Now, what you have to do next, I've added the instructions here for you to follow. So go to the web page, click on the DAG. This is it right here. And then toggle the button to enable it. So you need to first enable it with this switch. This will turn it on. Next, you have to click the play button to run the DAG manually. And that will manually trigger it. Because remember, in our Airflow script, under the schedule, I said none. Because of course I have to trigger it right now. If you want to trigger it daily, hourly, or whatever, you can just specify it here like a cron job. I'll trigger it manually, so I'll press this play button here. I'll do a single run, select trigger, and this should start running. I can go in here and you see the results. We had a decide retrain branch, successful, no retrain was successful, and retrain model is red one, which shows skipped. Now the reason why I skipped is because, remember, when we generated the drift and checked it, it actually created a retrained model here. So even though we created a drift, all right, that is already factored in the model that we've loaded into Airflow. That's why I skipped retraining. Now I'm gonna trigger it one more time and see what happens. Trigger. And you see it's running. can also use this button here to see how it actually does. You see here it's deciding whether to retrain or not. If there is no drift, there will be no retrain. If there is drift, then it will retrain the model. So that's essentially how it works. And these are the 2 runs that we've done so far. So as a summary, so first, the Airflow will decide whether to retrain the branch or not. And to do that, we'll run the check_drift.py script to check if the drift was detected. This is going to return retrain model or no retrain as the next task. Under the retrain_model task, it's going to retrain the model if drift was detected. And then all retrained models will be versioned so that they can be saved separately. Now, if the no retrain task comes up from here, then the next task is just going to be to skip training the model. In that case, we are going to keep using our baseline model that we had from the beginning inside the models directory, which is right here, this model. If you want to find where the retrained model is stored, it's going to be stored inside this retrained_model directory. There it is. Before we leave, let's do a little cleanup. I'm going to clear the screen here. Now remember, all of these things are still running. Okay. You can exit out of them or just run docker ps. These are all the containers. You can run docker compose down to remove everything. Okay. So you can run this, copy that, paste it here, and then you run the docker command. Then we have to deactivate our virtual environment here. Remember, we had to activate it for all the terminals. Paste it here to deactivate it. Next, we have to remove our virtual environment, the config directory that we created for Airflow. See the airflow.config there. The logs, let's see if there were some logs. Yeah, there were. And then plugins. There it is. It was empty, but we have to remove all those directories using this command here. So copy this. Now I can run it here. Now for the rest of the stuff, so I'm just gonna push everything. So cd ... gonna do git add, git commit, git push. That should push all changes. Let's go to our GitHub repository here. Refresh this. And you should see everything here. Thanks for joining me on this video. I'm still a young channel and I'm trying to grow. So like, comment, and subscribe to my channel for more videos like this. And I'll see you on the next one.